messing around with functions quite a bit. So we're gonna start with let's see. So here's like starter themes. Oh, well, this makes sense. We should probably do this on Mars. That makes pretty good sense to me. All right, so I started with a Mars template here. And let's set up our scene. So what we're going to effectively do right here is we're going to create a, for starters, a math genius. So we're going to be working on writing some functions, working on some programming logic, stuff like that. So we're going to create a dude who knows how to do a bunch of math stuff. Okay, and we're going to start experimenting with that today. So let's see. We need to find our smart guy here. Oh, wait a minute. So I guess the real question is our math genius? Is it a what kind of dude is it? Is it a biped, a flyer? Quadruped? Is it a fish? Do we need a fish on Mars? Maybe. So here we'll go with biped. Here's oh yeah, we'd have an alien on Mars, right? A Martian dude. Let's see if there's anything better than that. This could be a Martian. Is that a mouth? Okay. Why would there be pandas on Mars? I think we go with the guy with the mouth for stomach. Okay, well, so that's saying that's a weird name. So we're going to call him Ted. All right. So that's Ted. And did Ted go out there? There he is. Let's get over there to Ted. So we'll put him here. There we go. That is a mouth, right? I think so. There we go. Things on Mars are bigger. It's a gravitational thing. Okay. So there's Ted, and let's run this real quick and make sure Ted's in scene. Okay, so a couple things we want to be able to do. Additionally, we're going to be interacting with Ted, so we need to be able to get user input and prove that that is something that we can have happen. So we have our first method guy here. I'm going to just rename this. Can I rename this? Yeah. So we're going to rename this I'm going to name this main method. And this is going to be kind of compatible with a statement that exists across most of our programming languages. Open up Keynote here. All right, so that's this idea that, so main. All programs begin and end with main. We see this in Java, we see this in C++, we see this in C#. Basically every single programming language that we've discussed in terms of coming off of that historical C programming language as our starting point has something called a main method. Underneath the hood here in Alice actually is built on top of Java, so also there's a main method. But since Alice abstracts that from us and we don't actually see those details, we're going to artificially create it here by generating our own method here called the main method. Okay, so that'll put that little hint in our mind from when we start transitioning to Java at a later date. All right, so that's what we'll always rename our thing. So our main method is actually owned by the scene, and it gets the ball rolling. So when the scene is first activated, what does it do? It calls main. Okay, that's how our traditional programming languages work as well. Okay, so what are we going to do in main? Let's see. We're going to click on our scene, this, and here's our information for prompting a user. So under this, which is our actual scene, when we go to functions, we have a whole bunch of stuff with things in the scene and atmosphere and things like that. But down here we have things for prompting the user. So we want to get an integer from the user right now. All right, so we're going to drag this guy out here. Actually, we need to be able to store that somewhere first. So initially, let's just let's click on Ted here. Actually, we need to do it up here. And we're going to have Ted remember a piece of information. So here's Ted. I guess I expected it to say Ted here, but whatever. Oh, no, what we're doing here is when we click on something here, we are saying that all things of this type get an additional property. And we're going to call this user integer, user int. So it's going to be a variable of type whole number, and we're going to call this guy user int, and we'll start it off at 0. So now every single instance we might have of this Mapinguari, that's got to be from some cartoon or something like that. I don't think they just sat there and decided to just make up that name with like a random random name generator. But now, anytime we create one of these Mapinguaris, he will have that property. Okay, so they all are able to hold this single whole number that we happen to call user int.
The thing is like a Bolivian Bigfoot.
The Bolivian Bigfoot, does he have a mouth for a stomach? Is that a thing?
Second mouth on his belly.
What's actually interesting is as I look around the room, is you were mentioning this, and I say, is there, does he have a mouth for his stomach? Like several people all like looked forward to their laptops, like like a bunch of people looked it up, right? All right. Yeah, so this makes perfect sense for a Martian guy. We'd expect to find, I mean, Mars, Bolivia, same place, right? It's not the same place? Have any of you been to Bolivia?
Its skin is not penetrable by bullets or arrows.
Yeah, it's a Martian thing. Everybody knows that. We're gonna, by the time we're done with this, we're gonna have all sorts of canon for this creature and how the Martian atmosphere and the distance from the sun creates it's like a Superman type of thing, right? Yeah, when he came from Krypton and came here and the sun does some stuff, the same thing. Hey, this guy got on the wrong boat out of Bolivia and ended up in Mars. It's like it's the Bolivian space program. So they don't really talk about it on the news very much, but it's very much inactive. We actually have do any of you know Amish from the computer science program? So we have a guy in the computer science program who actually sat right here in CSC200. That's the first time I met him. He's a senior now. And very first day of class, there was I asked about some TV show, and he said, well, I don't really watch TV. So I figured, oh, well, doesn't watch TV, that means no TV, which means no electricity, which means he must be Amish. I mean, it's a reasonable... Name stuck. So now everybody knows him as Amish. But so we've had an ongoing joke that it's been even a quiz question before, the greatest failure of the 21st century was the Amish space program. And there's even like a thing from The Onion about they were NASA baffled by the failure of the all-straw space shuttle. Yeah, it's worth reading sometime if you get a chance. All right, so in any case, we have our Bolivian Bigfoot on Mars. And ours here, his name is Ted. We have added a property to the blueprint that these Bolivian Bigfoots are built off of, and Ted then inherits that property. All right, so what we want to do is we want to go ahead and set Ted's user int property. We'll start it off at a 0 for it now. And we want to set it to some user input from our user, where we're going to go to the functions for our scene. So our scene knows how to prompt the user for stuff. And we're going to get an integer from the user. And we're going to give them a custom message. Please enter a number. I doubt very much that Bolivian Bigfoots are that polite, but we're going to go with this anyways. Okay, and so we'll read in that number, and then we'll go ahead and ask Ted to repeat the number, proving that he read it in. All right, so we'll have Ted say something, and he's going to say, actually, we'll initially have him say hello, because we're going to modify that. So we're going to change this to this, and it's we'll start it like that, and the you entered something like that, the space, and then we'll go ahead and get the user's integer. All right, and we'll have that pop up for a couple of seconds. All right, so we're going to ask the scene to prompt the user for a number. The scene then is going to, when the scene reads in that number, it's going to store that value inside of Ted's user int variable. Then we'll have Ted say the value of his user int variable, proving that we were able to get information from us into Ted's memory. Make sense? And let me go ahead and save this before I forget. So we're going to call this guy, wasn't I saving it in a different place though? Did I create a 200 thing? And yeah, here we go. We're gonna call this one Ted. All right, so there's Ted. Perfect. All right, so let's run this, and we should get prompted. Please enter a number. We're gonna say 15. Hit OK, and there's Ted. You entered 15. Okay, so Ted now knows how to get some information from us. So now we want to give Ted some abilities, because everybody knows that Bolivian Bigfoots on Mars are math geniuses. It's part of the canon. It is now. It's actually the mouth, the brain that this mouth is attached to is the genius part for math on Mars. The top part is kind of a, did you see the newer Beanstalk, Jack and the Beanstalk movie? Where it has the Eton guy who leads the Giants, and he has like the dummy head and then the regular head. My wife and I like the dummy head guy. He wears a little helmet when they're going to war, and he doesn't speak English that well. I'd read that, look at that movie after you read the Onion article on the space shuttle, the straw space shuttle. Okay, so let's go ahead and teach this guy to do some math stuff. And we're going to do this through functions. So we're going to go and we're going to teach all of our, I wish we could just rename this to Bolivian Bigfoot. All of these guys, we're going to teach them some procedures and some functions. So we're going to give this guy a function, because functions ultimately boil down to a value. So we're going to create a function that can take in a number, does something to that number, and spits the result back out. Okay? And then we're going to use that result. So we're going to add a function to this guy. And we're going to start off by keeping this simple. We're going to teach Ted to identify even versus odd numbers. Okay? But we're going to give him a couple of abilities. Instead of it returning maybe a string, even or odd, that would be a procedure. We're going to look at both of these. We're going to have him we're going to have a function called isEven and another one called isOdd. So this guy's going to have a return type of a Boolean, and we're not dealing with arrays yet, so don't click that. And we're going to call this guy isEven. All right, so here is Ted's function for isEven, And the is-even function is going to require us to pass it a number that we're going to determine if that's even or odd. So now, making our connection here, if we're kind of introducing languages like Java or C and C++ at the same time, let me just get this. What we just did here is we're creating a function, so I'm going to write the Java equivalent, that returns a Boolean called is-even. So that's what we have so far. This will be the actual implementation code for it. Just left justify this for right now. Okay, so as we're growing this is kind of what's happening under the hood in terms of Java code. Okay, so that's what we currently have, is we have something that returns a Boolean. Its name is even. Now we're going to give it a parameter. In order to determine if a number is even or not, I have to, if I ask any of you if a number is even, you are going to require one number from me, right? You're not just going to guess at what number I'm thinking. So we're going to give this guy a whole number called value. Call it value, call it number, call it the number, whatever. We'll call it value. All right. So now this guy is going to take in a whole number value. So if we look at how Java just grew, now this guy took in an integer called value. All right. All right, so now we're going to do our statements here. So we're going to ask a question. We want to know if value is evenly divisible by 2, then we should return true. Remember, this is a function. Functions return a value. Procedures don't. We're going to see the difference there here in a few minutes. But this guy is going to do some math calculations, ultimately determining whether or not something is evenly divisible by 2, or whether the parameter value is even, and spit out either a true or a false. Okay? So notice this guy is saying a return statement is required. So since we've advertised we're going to return a Boolean, this guy expects us to eventually return something. Right now we're not returning anything, hence the big red thing. Java works the same way. If we're going to advertise that we're going to return something like this, somewhere in here we have to return something like that. Okay, so we're going to start off, we're going to ask a question. So I'll throw a question out there. And the question we want to ask is actually a math question, right? So we want to ask, let's see, whole number, so we'll ask this, the equal, actually we'll do this one. So what we're going to do is going to be integer. So relational whole number, we'll do the equal, we'll just do 0 and 0 initially. So what we want to know is the number that was passed in. And the number that was passed in is called value. And let's see, how do we get at value? Right there. So notice it was provided to us as one of the options here. So value is a variable that has a local scope to this function. It lives and dies with this function, so it's a new value that's available to us. So we want to know if value, when divided by 2, has a remainder of 0. So we need to make this guy a math function. So we want to look at value. We want to look at the remainder. So a value, when divided by 2, has a remainder of 0. If that's true, so if value divided by 2 has a remainder of 0, if that's true, we want to return true. Otherwise, we want to return false. So let's see, here's our return statement. We're going to return true if it is evenly divisible. We're going to return false if it's not. That makes sense? All right, and if we were to expand out our Java and see the same thing, we come in here and we would just say if value mod 2 is equal to 0, return true, else return false. So So that's the Java equivalent of that code. All right. So we can see here that the logic isn't any worse, but there's more opportunity for us to make syntax errors here, right? For right now. But hopefully you see there that you could actually accomplish stuff substantially quicker once you're used to writing code like this than you can with all the drag and drop crap out here. You're just less prone to mistakes with the drag and drop. That's why we use that here for a while. Okay, so this is TED's is-even function. Now this is an untapped resource. TED knows how to, if given a number, determine whether that number is even or odd. Okay, well, specifically, he's able to tell you true or false whether it's even. That's what he's actually able to do right now. All right, so we're going to go back to our main method. And we've proven that TED knows how to print out a value. So he's going to say, here's the value you entered. And now we want to have TED spit out the result of his function passing it that number. So we'll click on TED. We're going to have him say something. And we'll just put hello for right now. And we're going to change this to a custom that number. Well, let's just do it like this for right now. Is even. And we're going to, oh, it was actually this one we wanted to change to is even. And we're going to change this to calling a function. Which function? TED's is even function. Passing it a value. What value? Just pass it a 0 right now, but we want to pass it TED's get user int value. So TED's going to now call his is even method, passing it the user's integer, and ultimately we're going to concatenate that onto the string is even, and he's going to say true or false. Make sense? So we'll go ahead and run this, and let's go ahead and enter in a odd number, 15. So TED's going to take in that 15. He's going to say the number you entered is 15, and he's going to pass 15 to his is even function, which should spit out a false, right? 15 is a false number. So TED's going to say is even question mark, and he's going to say false after that. So there's the is even false. As opposed to if I give him a even number 4, he should spit out true. Make sense? All right. Let's go into TED and let's add another function called isOdd. IsOdd is going to have a return type of Boolean. It's going to take in a variable. You can name your variable whatever you want. Just know that whatever you call it here is going to be how we refer to it inside of the function. So for instance, if we look at Java here, I took in a variable called value here, so I have to use a variable called value in here if I want to do stuff. I can't take in value and then use something called elephant in here. I'm just making stuff up. Okay, so here's TED's is odd. So we can write something pretty similar to what we had before, right? Or I think we should, I assume this guy exists. Do we have a not? Let's try to return what I want to try to return here. So we're going to change that, and we're going to, yep, here we go. We're going to do a not true for right now. And really what we want to do is return the result of not is even on the value. So rather than write the logic a second time, we're just going to go ahead and have Todd, Ted, if you've asked me if this number is odd, I'm going to pass it to my is even function. And then I'm going to, whatever you give me back, I'm going to not that. So if you give me back a false, not false is true, which means the number is odd. Does that make sense? So when we not that value, if I pass 4 to is even, that's going to come back as true. When I not a true, it's going to turn into a false. Is it true that 4 is not odd? Is odd should return false for 4? Yeah, so it inverts it. That's what not does. So rather than writing all that logic again, all this is even logic again, we're instead just going to have is odd call is even and invert whatever the answer was. Because is odd is the opposite of is even. All right, so now this guy knows how to do is odd. So we'll go back to our main method. Let's see. Well, here we'll just do this again. We'll have Ted. Click Ted. We'll have him say something. Say hello. Initially, we're going to have Ted say change this to a custom string. We'll say is odd. And then we're going to have him call his is odd function. Passing it the user integer. So these two should always be opposites of each other, right? No matter what value I pass in. Go ahead and run this. So if I pass in a 4, that's true. For is even, should be false for is odd. If I pass in a 7, should be false then true. All right, that makes sense? Okay. Now, to show the difference here, we're going to go ahead and add a procedure to our Bigfoot. So we're going to add a procedure to this guy as opposed to a function. Remember, functions return a value, procedures don't. So we're going to add a procedure, and we're going to call this guy say even or odd. And we'll have this guy take in a single parameter. So he's going to take in a whole number, and we'll call this value again, but understand you don't have to call it value. We can call it whatever we want. In fact, here, we're going to call it whatever we want. We're going to call this elephant. Okay. Good programming practice would say your parameter name should be meaningful, but just to prove the point that it doesn't have to be called something very meaningful, we're going to call this guy elephant. So now what we want to do is we want to say that number is even if it's even. Otherwise, we want to say that number is odd. Okay? So we're going to ask a question. The question we're going to ask is even, oh, I could have passed an elephant right there. I didn't, but actually let's change this. So if is even elephant, then we're going to go ahead and say something. We'll do that. And we're going to go ahead and do this guy. All right. And do we have a convenient way of getting, probably just the drop down. Yep, there it is. So our parameter here, elephant, is a whole number, so we'll find it in the whole number drop down here underneath elephant. Okay, so there's elephant. And we're going to then add a custom string, put a little space, we'll say is even. All right, otherwise I'm going to copy this, copy the clipboard, then we'll drag this from the clipboard down to here. and we'll say this guy is odd. All right, so the say, even, or odd procedure takes in a single parameter, asks whether that parameter is even using the function that we already wrote, and then says it's even or says it's odd. He does not return a value. Difference between procedures and functions. Okay? Go ahead and store this. Go back to our main method, and now we're going to go ahead and call upon Ted's say, even, or odd function, and we'll pass this guy Ted's get user input value, or user int, get user int value, and it should then say whether it's even or odd. So we'll give it 15. So now we should get false, then true, then odd, right? There's our false, there's our true, there's our odd. All right. Similarly, if I restart it and I say 6, now we should get true, false, even. All right, so true math geniuses on Mars. But you want to make sure you find the ones that have the mouth stomach thing, because if it's not one of those, they don't have the same. Okay, they're not brainy. There's the punchline. Okay, so far so good. Understand the difference between functions and procedures, that kind of stuff. If we were to write this same thing out in Java, you know, the procedure version of this guy, since we already wrote is even, would look like this. We would return nothing. Just to save a little space, we're going to say P, even, or odd. This guy will still take in a value. We're going to ask the question if is even value. That's a true statement. We're going to print, it's actually system.out.println, but let's just say even right here. Actually, let's just do value is even, else value is odd. And actually, I'll change the system.out.println, system.out.println, and we'll just shrink this guy down a little bit. All right, so this is the Java equivalent of that procedure. So its return type is void as opposed to a number like a Boolean or a value like a Boolean. It's going to take in a value, it's going to ask a question, and it's going to do something as opposed to return something. This is equivalent to saying something. This will print it on the screen, as opposed to this guy over here where he doesn't say anything. He could say something. We could certainly say something in here if we wanted to. Like I could say about to return true, and then actually return true from it. That makes sense, the difference between functions and procedures? So understand over here in Java, the differentiation happens at the return type. So a procedure returns nothing, so we put in the word void there. A function returns something, so we put in something that is not void there. Java doesn't have a distinction otherwise. Okay, so let's go back and let's look at another function that Ted could do. All right, so Ted is going to find, we'll add a function. It's going to take in a whole number again. Actually, it's going to be his return type is going to be a whole number as opposed to a Boolean. So he's going to do some calculations and ultimately return a whole number. So Ted is going to take in two numbers. So we're going to call this guy addNums. And he's going to take in two parameters. We're going to take in a whole number num1, and we're going to take in a whole number, num2. All right, so like that. And then what we're going to do is we're going to return a math statement. Let's just start with that. Here's our math statement. Two numbers added together, num1 and num2. And that's what we'll return. Fair enough. So not a huge deal. So it's a function called addNums, takes in two separate parameters. Both of these guys are whole numbers. So this is a strongly typed language. We specify that num1 must be of this type, num2 must be of this type. We'll add those two guys together, ultimately return the result. That result will come out as a whole number, and somebody else will have the option to use that number. Go back to our main method now. And let's get rid of a few of these things. So let's just delete. Delete. All right, we're actually going to delete all of this. And we're going to go ahead and we're going to click on Ted. And we're going to tell Ted to say something. What's he going to say? We'll just say hello for right now. He's going to say the result of his addNums function. Can't just drop that directly in? Looks like I have to do it something like that. The sum is, then I should be able to drop it in here. Yep, I always have to have a string in front of it, looks like. All right, so we'll just put a 0 in for right now and another 0. All right, so addNums takes two parameters, so we're going to get two parameters. We're going to click on our scene, this, and we're going to go ahead and get an integer from the user. Enter a number, and we'll go ahead and get another integer from the user. Enter another number. All right, so rather than storing those two numbers like we did before, where we had Ted remember the number that the user put in, this time we're just directly asking the user for some values. We're immediately passing those values into the function. The function is doing its thing with those values, spitting out the sum, and we're printing the sum. Nowhere in here are we choosing to remember those values, any of the values. We're not remembering the first number the user entered in. We're not remembering the second number the user entered in. And we're not remembering Ted's sum. We're printing it, but we're not remembering it. Okay, so when we get to this next line here, all those that stuff's been lost. Okay, Ted has, I mean, as smart as he is with math, he has very short-term memory issues. All right, so we'll go ahead and run this. Enter a number, so we'll do 4. Enter another number, we'll do 7. Hello, 11. Oh, because I didn't change the word hello to the sum is. I thought I did. The sum is, there we go. So now it'll say whatever the sum is. 4, 11, there's a 15. Make sense? Okay, so we're able to pass those values in directly as well. Okay. Let's give Ted a couple more things. So let's tell Ted, we're going to give him a procedure. And this guy is going to be called countdown. All right. Ted's procedure is going to take in a whole number called starting value. And he's going to count down from his starting value to 0. All right, so just like, 10, 9, 8, 7, 6, blah, 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 like that. Okay? So here's Countdown. He's owned by Ted. Well, he's owned by all of our Bolivian Bigfoots, but we only have one of them on Mars, so that's Ted. And we're going to go ahead and write this. So we're going to go ahead and we're going to say count. Actually, let's do it as a while loop. So while, we're going to change this to a math function. And we're looking at whole numbers. And we want to know the current value of starting value as long as that is greater than or equal to 0. So the first one's going to be starting value. So as long as starting value is greater than or equal to 0, we're going to go ahead and print out starting value. So who's going to print it? This is current. Okay, yeah, this is this guy. So notice here that when we're in here, this is no longer the scene. This is actually our Bolivian Bigfoot. So the value of this has changed because of our context. We are inside of a procedure that Ted has. So inside of this procedure, we have a keyword called this, and this keyword is how an object refers to itself within itself. So if I'm inside of this procedure and I say this.say, I'm talking about Ted. Make sense? So I'll go ahead and put out the starting value there. And we're going to say, actually, let's go the other route. Let's change this guy to the whole number, starting value, and we'll change this guy to a string. Custom text string. We'll just put an exclamation point on there, so it'll be like 10, 9, 8 with exclamation points after it, right? Okay. Now, if I run this right now, we have an infinite loop. If I pass in a 10, starting value will come in for a 10, and Ted's going to say, is 10 greater than or equal to 0? Yep. Print out 10. Is 10 still greater than or equal to 0? Yep. Print out 10. Over and over and over again. Go ahead and run that. We'll see that. Go to our main method. Go ahead and delete this. We're going to ask Ted. Here's Ted. We're going to ask him to do a countdown. And let's just count down from 3 for right now. We won't read anything in from the user. And he's going to just say 3 over and over and over and over again. So we're passing in 3 as our starting value. And Ted's going to be stuck. 3, 3, 3, 3, forever and ever and ever. Because we didn't modify that value. A loop keeps going as long as the Boolean expression remains true. What's the Boolean expression? Any expression that boils down to a single value of true or false. All right, so now let's go ahead and we'll add some user input into this. So rather than 3, we'll go ahead and ask our scene to get some user input. So get a integer from the user, enter a number. All right, but now we need to go into countdown and modify this guy. So what he needs to do is he needs to subtract 1 from starting value. Okay, so we're going to go in here and we're going to, let's see, do we have a, that's going to be interesting. Guessing we have to do it here. Yeah, there we go. So starting value. Oh, that's interesting. I kind of want it to be the other way. I want starting value to decrement. Can we not do that? Looks like we might not be able to directly change this value. In Java, we could say, I want if starting value start at 5, I could make it go down to 4, then 3, then 2, then 1. I don't see a convenient way, maybe a variable? And that's creating a new variable. I was hoping, oh, hello. I was hoping assign would do what I wanted to do. But the only value we can assign is to our own properties. So we can go ahead then, is up top here, we can set our user int to our starting value, and then say as long as our user int is greater than or equal to 0, we'll go ahead and print out our user int. And then we're going to assign our user int to be a, we'll just say 0 for right now, and we actually want it to be a math function, something minus 1. And what is that something? That something is going to be our current user int minus 1. All right, so it's not allowing us, at least I couldn't conveniently find a way to change the value of starting value. So we're going to temporarily store it inside of our own memory. All right, so the function took this in. We went ahead and threw it into our set user int. As long as our user int was greater than or equal to 0, we printed out our user int with an exclamation point. Then we reduced our user int by 1. Okay. Go ahead and run this. So we're going to count down from 5. So there's 5, 4, 3, 2, 1. Okay, and now he's done. What we probably would want to do after that is maybe do something like liftoff. So say liftoff. All right, so run that again. We'll just do a countdown from 2. Okay, so homework assignment, which I won't forget to put up, is to create a function for calculating factorial. The factorial of a value, like for instance 4 factorial is 4 times 3 times 2 times 1. Okay, that's the factorial of a value. So you're going to write a function called factorial. It's going to take in a whole number, and it's going to spit out the factorial of that number. And then prove it works by displaying the factorial of some number. Make sense? Okay, so factorial will multiply 4 times 3 times 2 times 1. You have a model here that counts down from, for example, 4, 3, 2, 1. Well, this one goes all the way to 0. So now, instead of subtracting 1, maybe you do some multiplication in there. Make sense? All right, I will see everybody on Friday.